Hi, our group assignment is about Radiowave spectrum allocation. First of all, what is Radiowave spectrum allocation? Radiowave spectrum allocation is the process of dividing and assigning specific radio frequency for different use, like TV, radio, mobile phone, Wi-Fi, GPS, satellites, and more. The spectrum used for wireless communication is a limited resource. Any connection on a designated spectrum band has a set bandwidth, the maximum amount of data able to transmitted over a connection in a given amount of time. Overusing a single spectrum band can interrupt or block critical signals. To avoid this, users must work in a coordinated system typically run by a national or international regulator.
The radio spectrum is not just about frequencies. It's like the lifeblood of modern communication. It powers everything from the internet and phone call to GPS and emergency service. Enable of connectivity. Spectrum support vital technology like 5G, 4G, Wi-Fi, satellite communication, broadcasting, and more. Without it, none of this would work. Economic engine. The wireless industry play a huge role in the global economy. In fact, in the US alone, it adds more than 700 billion each year. Critical public service. It also essential for things like emergency response, air traffic control, and national defense. So good spectrum management is about safety too. Growing demand by 2027, mobile data traffic is expected to quadruple. This shows we urgently need more efficient and fair use of the spectrum.
Global governance. The International Telecommunication Union, ITU. The ITU, a specialized agency of the United Nations, has been coordinating global radio spectrum use since 1865. Its work is fundamental to ensuring a harmonious and interference-free wireless world. Role: coordinates global radio spectrum use and satellite orbits. World Radio Communication Conference. Major conference held every 3-4 years to update international radio regulations. Outcome: establish global frequency allocation and technical standards which are legally binding for member states. Impact: WRC 90, for example, allocated critical frequency bands 24.25 to 27.5 GHz specifically for the development and deployment of 5G networks worldwide. National regulation, implementing global policy locally. While the ITU sets global guidelines, national regulatory authorities are responsible for overseeing domestic spectrum allocation and licensing. They translate international agreements into actionable local policies, managing the intricate details of spectrum use within their borders. Key regulatory bodies: Federal Communication Commission, FCC, United States; Ofcom, United Kingdom; Telecom Regulatory Authority of India, TRAI, India; Anatel, Brazil. Responsibilities: issuing license for spectrum use, enforcing regulation and standards, developing national spectrum policies, managing interference between services.
There are a few common methods, which is auction method. This is the most popular approach. Companies buy from the right to use certain frequencies. It helps government raises money and ensure efficient use by letting market demand decide the value. The second one is beauty contest. These are not actually contests. They are eventually where regulation choose the best applicant based on things like technical skill or service plan. It's more about merit than money. And the third one is administrative assignment. Sometimes the spectrum is given directly to government agency or industry, like for public safety, based on specific rule. Fun facts: since 1994, the US government has made over 130 billion from spectrum auction.
Right now, I'm gonna tell you about spectrum management strategies, maximizing efficiency. Effective spectrum management aims to maximize utilization, minimize interference, and foster innovation within the finite resource of radio waves. This involves a variety of sophisticated techniques, leverage technological and advancement. The first point is spectrum refarming. Reallocating existing frequency bands such as repurposing 2G or 3G spectrum for newer 5G technologies to optimize usage. The second point is DSA. What is DSA? DSA is dynamic spectrum access, enabling opportunistic use of temporarily unused spectrum, allowing devices to intelligently identify and utilize available frequencies. The last point is spectrum sharing. Spectrum sharing, allowing multiple users or services to share the same frequency band as seen with the Citizen Broadband Radio Service (CBRS) 3.5 GHz bands in the US.
Next, the allocation of radio spectrum faces ongoing challenges, driven by exploding demand and the inherent scarcity of usable frequencies. This necessitated constant evolution in regulatory approaches and technological solutions. Exponential growth in 5G, IoT, satellite broadband, and connected vehicle intensifies the demand for prime, contiguous low and mid-band spectrum, which is increasingly scarce. Complex coordination is needed to prevent disruption, especially across international borders. New paradigms, including the exploration of millimeter waves, sub-6 GHz, and unlicensed bands, are crucial for expanding capacity and fostering innovation.
Conclusion: the ongoing imperative of spectrum management. 1. Key takeaway. Key takeaway is radio spectrum is a finite, fundamental resource, critically managed through integrated global and international framework. 2. Collaboration. Success allocation released on deep international and national cooperation to ensure seamless connectivity and prevent interference. Adaptation. Policies, regulation, and technologies must continually evolve to meet surging demand and foster innovation in wireless communication. Future outlook. Expect a shift toward more flexible sharing models, denser network deployment, and the exploration of new frequency frontier to substance growth.
This
Reference from us. That's all for us. Thank you for your attention. We appreciate your agreement and welcome any question you may have about radio wave spectrum management. Thank you. Assalamualaikum.